The AI Engineer's Trinity: Skills, Tools, and Strategy for 2026. You want to build a career in artificial intelligence. You see the opportunities, the exciting projects, the potential. But right now, you're facing 3 critical decisions that could make or break your journey. First, the framework dilemma. PyTorch or TensorFlow? Which one should you invest hundreds of hours into mastering? Second, productivity. How can you keep up with the insane pace of development without burning out? And third, future-proofing. What skills will still matter in 5 years when AI is even more advanced? Getting any one of these wrong could cost you years of progress. But today, we're solving all 3. We'll break down the ultimate framework choice for your specific goals, master the #1 AI coding tool that's changing everything, and map out the exact skills that will make you irreplaceable by 2030. This isn't just another tech comparison. This is your career blueprint. Let's begin. Let's start with the great debate, PyTorch versus TensorFlow. Forget asking which one is better. The real question is, which one is better for your career path? Here's the fundamental difference. PyTorch was built with a research-first philosophy. It's dynamic, intuitive, and feels like native Python. When you're prototyping a new neural network architecture or experimenting with a research paper idea, PyTorch gives you immediate feedback. You can debug line by line, change things on the fly, and focus on the idea rather than the infrastructure. That's why you'll find PyTorch in over 80% of academic papers and cutting-edge research today. TensorFlow, on the other hand, was engineered with production first in mind. Its original static graph approach, while more rigid, creates optimized deployable models. Think about serving predictions to millions of users, running on mobile devices, or integrating into large-scale enterprise systems. TensorFlow's ecosystem, with tools like TFX for pipelines and TensorFlow serving for deployment, is incredibly robust for taking models from experimentation to real-world impact. So here's your career decision matrix. If your goal is to work in research, academia, or at startups pushing the boundaries of what's possible, PyTorch should be your primary focus. The learning curve is smoother, and you'll be speaking the language of innovation. If you're targeting roles in large tech companies, enterprise AI, MLOps, or embedded systems where models must be reliable, scalable, and maintainable, TensorFlow expertise remains highly valuable. Many legacy systems and production environments are built on it. But here's the most important insight: the concepts transfer. Once you deeply understand how neural networks work, learning the second framework becomes significantly easier. My recommendation? Start with PyTorch to build your fundamental intuition, then learn TensorFlow's deployment patterns when you need them. Check job postings for your dream roles. That will tell you what the market demands in your specific niche. Now let's dramatically increase your productivity. You have your framework chosen, but writing all that code can still be slow. This is where GitHub Copilot changes everything. Think of Copilot not as just an autocomplete tool, but as your AI pair programmer. It understands context, it understands machine learning patterns, and it can save you hours every single day. Let me show you what I mean. Instead of just generating boilerplate, we're going to use Copilot for complex ML-specific tasks. First, data validation. Instead of painstakingly writing checks for your dataset, try writing a comment like this. Create a function to validate image data. Check dimensions are 256x2156. All pixels are in 0-1 range, and no images are corrupted. Copilot will generate a robust validation function in seconds. Second, setting up a complete training loop. Start typing def train epoch, and let Copilot suggest the entire structure: loading batches, forward pass, loss calculation, backward pass, and optimizer step. It knows the PyTorch or TensorFlow patterns. Third, creating tests. Write, test that the model output shape is correct for batch size 32, and watch Copilot write a proper unit test using PyTest or unit test. Fourth, API deployment. Type, create a fast API endpoint that takes an image and returns predictions, and get a complete working endpoint skeleton. The key is learning to write clear, specific prompts. You're directing the AI. Instead of typing every line, you're reviewing, modifying, and architecting. This shift, from being the typist to being the director, is what gives you 10x productivity. Measure your time saved. That 30-line data pre-processing function that used to take 15 minutes, now it takes 45 seconds. That testing file? 2 minutes instead of 20. This isn't about cutting corners. It's about focusing your human intelligence on the hard problems while automating the repetitive patterns. Tools and frameworks will evolve. What won't change as quickly is the need for certain human skills. As AI becomes more capable, the most valuable professionals won't be those who can write the most code, but those who can solve the right problems. Let's talk about what AI cannot easily automate. The skills that will make you future-proof. First, complex problem definition. AI can solve a well-defined problem, but humans must identify what problems are worth solving. This requires understanding business needs, user pain points, and technical constraints. It's about asking, what should we build? Not just, how do we build it? Second, cross-domain thinking. The most exciting AI applications happen at the intersection of fields, like biology and computer vision for medical imaging, or finance and natural language processing for market analysis. If you can bridge domains, you become incredibly valuable. Third, strategic communication. Can you explain your model's decisions to a non-technical executive? Can you articulate why certain ethical considerations matter? Can you mentor junior engineers? These human skills separate technicians from leaders. Based on this, here are 5 roles that will thrive in the AI economy. Number 1, the AI integrator. This person connects AI systems to real business workflows and human users. They understand both the technical possibilities and the practical constraints. Number 2, the MLOps engineer. As more models go into production, we need specialists who can build the pipelines, monitoring systems, and infrastructure that keep AI systems reliable at scale. Number 3, the AI ethicist and explainability specialist. As regulations increase and users demand transparency, professionals who can make AI decisions understandable and accountable will be essential. Number 4, the domain expert who codes. The biologist who learns enough ML to analyze genomic data. The designer who uses generative AI tools creatively. Deep domain knowledge combined with technical implementation skills is a powerful combination. Number 5, the AI product strategist. This person defines what AI products should exist, for whom, and why. They blend market understanding, user psychology, and technical feasibility. Your action plan? Dedicate 70% of your learning to technical depth, but 30% to breadth. Take a course in an adjacent field. Practice explaining technical concepts to non-technical friends. Work on projects that have real users, not just accuracy metrics. Learn about model deployment, monitoring, and maintenance, the full life cycle. So here's your 2026 blueprint in 3 steps. First, build your fundamentals with PyTorch for intuition and TensorFlow for production patterns. Second, master GitHub Copilot to execute with unprecedented speed. Third, orient your long-term growth toward integration, strategy, and human-centered skills. The goal isn't to compete with AI. It's to build the uniquely human layer of judgment, creativity, and strategic thinking on top of it. That is how you build a career that doesn't just survive the AI revolution, but thrives because of it. Now I want to hear from you. Which framework are you leaning toward? PyTorch or TensorFlow? And what's your next learning goal? Let's continue the conversation in the comments. If you want a downloadable 1-page cheat sheet comparing these frameworks with learning resources, check the description below. And if you're ready to see how all these pieces come together in a complete project, watch my next video where we build an end-to-end ML system using exactly these principles. Thank you for watching. Keep building, keep learning, and I'll see you in the next one.